The final way we have for measuring the spread of data is calculating what's called a standard deviation. Now, the standard deviation is nothing more than a measure of the average deviation from the mean. And I just want to bring you back very quickly to probability when we were dealing with what we call the normal curve. Okay, for the normal curve, we got something like this. And what we said was that in any body of data that is normally distributed, the mean is in the middle. There it is. Okay, any value that is not the mean is deviated from the mean. So that means there's a deviation this way to bigger values than the mean, and there's a deviation this way to smaller values than the mean. Okay, so what we do in the standard deviation is we give all the deviations an average value. So we collect all the deviations, we throw them into a formula, and then the formula, which we're going to use by our calculator, will kick out a value which is the average deviation of every data point from the mean. Okay, so that's really what the standard deviation is. Now, a very short class today, because I only want to focus on standard deviation. I want you to do questions dealing with the standard deviation. I want you to practice getting the standard deviation on your calculator according to the sheets that are on the slides and also up on the Google Classroom, and get used to it. Learn how to turn your calculator into the particular mode that is needed for this procedure. Okay, so it's not to be used if there are extreme values. Now, because it's an average, because it is an average measure of the spread of data, if you have values that are very, very extreme, now what I mean by that is very large or very small, or put another way, if you have values that are very, very far away from the mean, then this is going to skew your standard deviation terrible. Okay, so don't really use your standard deviation as a measure of spread if there is extreme values on either side of your mean. Okay, or if there are extreme values full stop in the body of data. Calculated, we use the following formula. So what we used to do, we used to have to draw a huge big table, and then we had to add up, do you notice that symbol there? That's a symbol for adding the squares of the differences between every data point and the mean, divided by the number of items in the data set, and get the square root of the answer. Okay, now that's if there was no frequency table. That's if it was just a set of data. Say, for example, you went into a class and you picked the number, the ages of everybody present, and you had a list of ages, you'd put them into that formula. But if there is a frequency involved, so if you're dealing with frequency tables, then you use the second one, which is the sum of the frequency multiplied by the square of the difference between the data point and the mean, divided by the sum of the frequencies. Now, in one sense, we're lucky that we don't have to kind of worry, well, which one am I going to use? I'm going to give you a procedure to use on your calculator that will basically get the standard deviation for you, whether there is just a set of numbers or whether there is a frequency. Okay, and that involves looking at the same procedure for turning your calculator into what we call frequency mode. Now, to do that, you must press the following buttons. So it must be Shift, then Mode, then down on the big button in the middle, then 3, then 1. You notice now it says on your calculator screen frequency on, so press 1. Your frequency is now on. So now you are ready to enter in your data points with their particular values. And also just remember, to the previous class, if your data values are given in groups, so let's say 0 to 5, 5 to 10, you use the mid-interval value as your data point with the frequency below, okay? Because you can only put into your calculator definite values. You can put in discrete values to your calculator, you can't put in groups. Okay. So how do we then go about putting the data points in? Well, first of all, you put your calculator into statistics mode. To do that, it is going to be mode 2, 1. Now, just watch your screen. Watch what the screen says every time you press one of those buttons. Then you press equals, and you'll notice now you've got your table. With your X's, they're your data points or your mid-interval values if you're using a grouped frequency table. And then your frequencies, which will be the bottom line of the table, telling you how many times each of those groups or each of those data points repeat themselves in a given list. Okay, and then all you've got to do, let's just take the example here. Let's take 1, 2, 3, 4 with a frequency of 1, 4, 9, and 6. So into the X column, you're going to put in your 1, 2, 3, 4. So 1 equals 2 equals 3 equals 4 equals. You'll now notice that's on the left hand side. Then you go up to the top of the right hand side using that large round button, and you're going to put in 1 equals, 4 equals, 9 equals, 6 equals. Once you've pressed your last equals, they are all in the memory. So you press AC, clear everything. Okay, and now you want to calculate the standard deviation. So to do that, we've got to go to shift 1. So we've got to go back into shift 1, which brings me into the setup for number 4, which is shift 1, my apologies. So shift 1, and then you've got 5 options. We're going to go for the 4th one, the variable 4, and then you'll notice the symbol. You can actually see the symbol for the standard deviation beside x. That's what we're looking for. This symbol here, this what we call sigma x, which is number 3, and then we press equals, and what do we get? 0.8366, or 0.837 if you want to round off to 3 decimal places. Okay, so that's as easy as you get the standard deviation. That's it. But I need you to practice that in order to be very, very sure of how to use this thing without any aid in the exam, that you can get the standard deviation, no bother, but that you can also get the correlation coefficient on your calculator. Those 2 methodologies you have to carry in with you. So what is sigma? What are the properties of sigma? Well, first of all, it measures the spread of data around the mean. Okay, so it can only be used when the mean is used as the measure of center. So if you're going to measure the mean, then you can measure the deviation from the mean. Now, we are, of course, always thinking of the normal curve, the curve that has a perfect symmetry. The mean is in the middle and the deviation is either side. Okay, so you can keep that image in your head, because we are going to use that moving into the last stage of this chapter in order to show you how standard deviation can be applied to the normal curve, and how the z-scores come back in order to allow them to work with different aspects of the various different statistics we're studying. Sigma will be 0 when there's no spread. Now, when we talk about a uniform distribution, let's say, for example, I had 10 data points, and say, for example, all the data points were 4. Well, then the mean would be 4, and there'd be no deviation, because every data point has exactly the same value as the mean. So none of my data points would vary from the mean. So there would be no variation, which means there would be no average or standard deviation from the mean. It's affected by extreme values. So if there are extreme values, we do not use it. You're better off to use maybe the range, or you're better off to use the interquartile range, because the interquartile range is not affected by extreme values. That all that does is it gets the quarter value, it gets the 3/4 value, and it subtracts the 2 to see what's between. But unfortunately, the standard deviation is very, very sensitive to extreme values. So if there are extreme values in your data, the standard deviation is not the way to calculate the measure of spread. Its units are exactly the same as the units of the data. So for example, if you're measuring heights, well then the standard deviation would be in whatever units you use to measure height, if it's centimeters. If you're measuring mass, then, and say you're measuring mass in kilograms, then your standard deviation will be in kilograms. Whatever units your data is measured in, your standard deviation will have exactly the same units. Okay, so let's just take a question. Let's take page 128, question 5, and let's take a look at this. A group of medical students measured the blood pressure of the same person. The systolic readings in millimeters of mercury, now that just means how far the mercury travels up according to the blood pressure that the cuff finds in your arm, are given below. 139, 131, 136, 141, 121, 126, etc., etc., all the way up as far as 160. So let's have a look. Give 2 possible reasons why there is a variation in the readings. Now, think for a moment. A group of medical students measure the blood pressure of the same person. How can one person have different blood pressure readings? Well, there's 2 very good reasons. First of all, they're students. So one of the biggest reasons why they vary is because of the lack of experience in using the equipment. Okay, they're students, they're learning. So therefore you could say lack of experience. The second one could be the person's own response to being used as an experiment by, in this case here, 14 students. Okay, so there's 2 things going on. There's the inexperience of the student, and then there is the actual internal response of the person towards 14 students taking their blood pressure one after the other. Okay, no wonder it goes up to 160. Anyway, so number 2, plot the data on a stem and leaf diagram. Now, again, thanks to technology, I can get Excel to do this for me. I've already pre-prepared the stem and leaf diagram, and it would look something like this. Okay, so in your stem, what have you got? In your stem, you have the multiples of 10. The lowest reading I can find is 121. The highest reading is 160. So therefore, in the stem will be 12 to 16. Okay, the leaves are the units at the end of each one. So therefore you'll have 131. So just to make sure we have all the numbers filled in here properly, let's start at the beginning. The smallest is 121 and it's present twice. Then we've got 126. Then we have 130. Then we have 131 3 times. Then we have 136, I think is the next one up. Then we have 139. And then we have 141, and that's present there twice. We have 143, 145, and 160. So they're all there, okay? 14 readings in the table, 14 readings on your stem and leaf diagram. Part 3, circle the outlier. Now, an outlier is a piece of data that is way out of sync with the rest of the data. Notice here that this data is kind of bundled around, it's between the 120s, 140s, okay? So it's kind of bundled around the 130, some in 120, some in 140. The majority seems to be in 130. But you've got this one out here, which is 160, okay? Now, obviously, sorry, I forgot to put in, my key would be 125 means 125. So you've got to put the key in, okay? Sorry, I meant to put that in also. Now, 160, that's way off. Most of the data seems to be in and around the 130s. Here we've got a 160. So that person, that student, has now failed and is gone. Okay, they can become a teacher or something. But you get the idea. So that's gone. Okay, failed. So that's 160 out of the question. It's an outlier. It's data that's way out of sync with the rest. And give a possible reason for the outlier in this data. Inexperience. Okay. But also, it's the last person. So maybe the person that's getting their blood pressure taken 14 times is just cheesed off. And because they're cheesed off, their high blood pressure has gone through the roof. I don't know. The one before that got 130. So suggest a reason. Answer, inexperience. You could also say maybe damaged equipment, I don't know. But inexperience seems to be the biggest one. Describe the shape of the distribution. Now, let me just get rid of all that. And don't worry about the key being gone as well. It would be there if you're writing it in. The shape of the distribution. You turn the stem into a horizontal position. And notice what you get. You get a quick rise followed by down like that. See? Now what's that? That is going towards the positive aspect. The tail is running into the positive aspect of the x-axis. So if I was to turn the stem this way, what I'm getting is something like this, which means that this is positively skewed. I hope that makes sense to you. Positively skewed data. In other words, it bunches up here and then it tails off to the 160. So you'll have your 120s here, your 130s here, your 140, and then you've got a 160 way out here. So it's positively skewed. The tail is leading off into the positive aspect of the x-axis. So that's the shape that this would have. Calculate the mean and the standard deviation of the distribution. Now the mean is easy enough. And again, bear with me because I'm going to do this on the calculator live. So I could make a mistake, but let's just shove it in. So what have we got? We've got 121 twice. That's 1, 2, 1. Then we've got 126. Then we have 130. Then we have 131 3 times. And then we have 136 plus 139. And then we have 141 twice. And then we have 143 and 145 and 160. Okay, so the total I get there is 1896. Now you can check that for me yourselves, but that's what I'm doing live, online, in relation to totting up just the blood pressures. Divided by, well, how many students? Well, there are 1, 2, 3, 4, 5, 6, 7, 2s, 14. So 14. So you divide that by 14, and the average comes out as 135.42. Now remember I said to you that it appears that the data is bunched around the 130s. So the mean, which is mu, actually reveals that the mean is 135.42. So the data is bunched around that number. That's your mean. Now how do you do your standard deviation? On your calculator, go back to the procedure again. So let's get into frequency mode and you can follow me with this. So shift mode, down with the large blue, 3 and 1. So you got your frequency on. Okay. Now by the way, there is no frequency here really. I suppose you can put them in as individual data points. That just means keep the frequency at 1 for everything. That's probably the easiest way to do it. Okay, or you could go back. Let's actually do this a different way. Let's go to shift mode. Just clear your calculator there for a moment. So shift mode, down 3, and let's press 2 off because we don't have a frequency here. Okay, now what do I do? Now I'm going to go into statistics mode. So mode 2 and 1. Okay, notice now it's only a table for the values that you have. So let's put them in. 139 equals 131 equals 136 equals 141 equals 121 equals 126 equals 121. That's the top line done. 131 equals 131 equals 145, 143, 141, 130 and 160. Okay, so all your data points are in. Now how do you get your standard deviation? You clear and then you go to shift. So shift 1 4 3 equals answer 10.07. Sigma equals 10.07. So in other words, all the data points that are not the mean have an average deviation of 10 units either above or below the mean of 135.42. That's what that means. Okay, so that's sigma, and all you've got to do, you don't have to show your work for sigma because you're using your calculator, but you do have to make sure that you put that C in a box around it to tell the examiner that you did the standard deviation through your calculator and not through that massively big stupid formula that we would have to use if we were just dealing with the numbers on their own. Okay, so you can use your calculator for that. Part 6. If a group of qualified doctors had taken the readings, would you expect the standard deviation to be greater or less, and explain your answer? Now, if we had a group of qualified doctors, we would expect the readings to come out almost agreeing with each other, maybe 1 or 2 deviations above or below a given value. Okay, qualified doctors would be much more experienced at taking blood pressure, so we wouldn't expect such a variation, which means the standard deviation would be less. Simple as that. And if they ask you to explain why, the standard deviation would be less because the readings that would be taken by the experienced doctor would be closer to one another and closer to the mean value. Okay, so that's just standard deviation done very quickly. I'm going to leave you off with those questions 127 to 129, 3, 4, 5, 6, 7, 8 and 10. You go ahead. That's just to get you into the habit of using your calculator for standard deviation, which we will be using in the next section now as we come towards the end of this chapter. So take them. We'll have a live class on Wednesday just to catch up with you to make sure you're okay with your standard deviation and your interquartile range and all of that. So Wednesday, live class.